So now in recent videos we looked at using a resistor to limit current through an LED. We lowered it way more than we needed to. The LED can pass about 20 milliamps of current pretty safely, and we're going to measure the current that this resistor will let pass through the LED with 5 volts power supply set to 5 volts right now. To measure the current, we just need a space somewhere along these 2 points here where we have a connection. So we could put it between the positive rail and the resistor, or between the resistor and the LED, which we have a gap there to take our measurement, or we could go from that's the anode, the long lead up there, the cathode to the negative rail. If we wanted to, we could remove that jumper and make a connection to those jumpers. But I like going between the resistor and the LED. And so no current's flowing right now because it's open. We will close the circuit through the meter. So the current going through the resistor and the LED is also going through the meter. And there you can see it's not perfectly 20 milliamps. It is going up though as the LED and possibly the resistor warms up. That's one problem with electronics. Sometimes more current flows as a component warms up, which makes it warm up even more and allows more current to flow. But in any case, you can see we limited below 20 milliamps of current pretty closely. So that's with a 150 ohm resistor. So now the best way to calculate the resistance you'll need for a given current you want is to take the voltage. Generally you know the voltage that you'll have, so it's 5 volts that I just used, and we wanted 20 milliamps of current. And so I wrote out the formula here. So the power supply voltage is 5 volts, but the LED is going to block about 2. That's pretty steady. No matter what voltage we use, it's going to block about 2 volts. And so we take the 5, subtract 2, we got 3, and then we divide it by the amount of current in amps. Remember to make the calculations in amps, not milliamps, when you're using Ohm's law. So 0.02, that'll give us 150 ohms, which I have, 150 ohm resistor. And so I already did the wattage rating. So wattage is the voltage times the current for a given component. So we know there's 3 volts across the resistor after the calculation. We can also measure that with the multimeter. And since we got 3 volts across it, it's 150 ohms, it'll have 0.02 amps, 20 milliamps of current, and that will be the wattage. So that is far less than the 0.25 watts that these are usually rated for. And you actually want to keep them about 0.125 watts. With this is slightly higher, but it's not terrible. But that's near its maximum wattage rating. And so in any case, we are really safe with that amount of resistance for the resistor overheating. And so now we're going to look at, I think this is infrared, but throw a camera there. I think this color though will show up the nicest. You can see that the resistor is still quite warm compared to the LED, but we do have about 20 milliamps of current going through it according to the power supply, and that is at 5 volts. And now I turn the output off so that the resistor can cool down, even though hopefully it wasn't terribly hot. And I'm going to swap the 150 ohm resistor for a 390 ohm resistor. Doing the calculation, I wanted a 400 ohm resistor, but this is the closest value I have to 400, and it's not too far below. It's safer to go higher. And then we will set the power supply up to 10 volts. Right there, the output is off right now. As I said, if I hit the power button, that actually turns the output on or off. And now you can see that the LED is on. And you can see we have the 20 milliamps of current. So more resistance, more voltage, and we have basically the exact same current. And now after waiting a couple minutes, we'll look at this. So it's probably harder to see the LED by a little bit. It's probably not as bright because this really compares temperatures. And so you can see that the resistor is probably a little whiter and the LED a little more grayer. And finally, I calculated I'll need a 650 ohm resistor to get 20 milliamps of current through the circuit, including the LED at 15 volts, of which the LED blocks 2 volts. And I have a 680 ohm resistor right here. So when I apply the power with 15 volts, then we will probably see slightly less than 20 milliamps of current, which you can see there. And now we're pushing the power rating of the resistor quite a bit, and so we're going to move in. Now you can see the LED is a very gray dark gray almost spot compared to the resistor. The resistor is really hot compared to the LED, and so we can't compare the resistors at the same time because the power supply voltage was changing, but the LED was probably maintaining the same amount of heat because it has the same amount of current going through it, and it's blocking the same amount of voltage. The rest of the voltage is going across the resistors. So as the voltage goes up, we're needing more resistance to lower the current, but they're still getting hotter, and basically they're knocking out some of the energy to protect the LED. So more voltage, more energy, the hotter the resistors get for a given current. And of course there's higher wattage resistors, so like in this case we would want at least a half watt resistor, 0.5, and I'm going to turn it off to hopefully prevent it from getting any permanent damage, but we're probably still safe because it's pretty much at a quarter watt. And so in any case, that's it for this video. We'll look at this in more detail in upcoming videos, but I wanted to make the point about the LED. It's really easy to protect it at low voltage with quarter watt resistors, and as we saw, the when we only had 5 volts, ultimately the resistor only had 0.06 watts across it, so we could use whatever value we want really to set the current that we want without worry. But with the 15 volts of the power supply voltage, we can't really get near 20 milliamps of current. We should go much lower to keep the resistor from getting hot. Use a higher value resistor, there'll be less current going through it, and it won't get as hot. So you have to make those adjustments. And so in any case, I'll pop up some other videos that you might like, and the subscribe button. Make sure you subscribe if you haven't and click the bell. Thanks for watching. I will see you in the next video.